Okay, this is the video notes for your Unit 5 test review. So we're going to go outcome by outcome, and whatever problems you have trouble with, just skip ahead to the video of that particular problem, and you'll find how to do that particular problem. So we're going to start off with outcome 31, which is graphing systems of equations. In graphing systems of equations, you take these two systems here. There's two lines, one line and a second line, and you're going to graph them both on the graph. Okay, wherever both of them cross, that is going to be the solution to your system of equations. So we're going to go ahead and graph these lines. I'll make them in different colors so you can see. The first equation has a y-intercept of 2, so it starts at 2. Okay. The slope is negative 1/2, meaning we go down 1 over 2, down 1 over 2, down 1 over 2, and we can even go backwards to complete our straight line. So we'll connect all these dots with a straight line. Okay. I'll do the second line in red. The red line, the next line, starts at negative 3 and then has a slope of negative 3, which means you go down 3 to the right 1. But since we don't have room for that, we're going to have to go backwards by going up 3 to the left 1. And we continue going up 3 to the left 1 and drawing the line between those. So you can clearly see where they cross. Okay, they cross at this point right here. They cross right here, right there, which that coordinate point is negative 2, positive 3. So our solution is negative 2, 3. And that's how you do the systems of equations. The second graph, we'll do the same exact thing here. The second graph the first one starts at 4. And then goes up 2, the slope is 2, so it goes up 2 over 1, but we can't go up 2 over 1, so we're going to have to go backwards by going down 2 to the left 1. And I'll keep going. Draw my line. Draw my second line in blue. The second line starts at negative 3 and also goes up 2 over 1. Here's that line. Now in systems of equations, the solution is wherever they cross. So if you run into a situation like this, where they do not cross, that is going to be no solution. Now you might have been able to figure this out without graphing it if you would have noticed that both of them have the exact same slope. Remember that if two lines have the same slope, they are therefore parallel, and parallel lines will never cross. Therefore, there is no solution. So if you found that out before, you didn't actually even need to graph this. You could have noticed that the slopes are the same. So it's parallel, and therefore there is no solution. So that is outcome 31. Now on to outcome 30 and 32. Now we're not going to do all of the problems here in 30 and 32. I'll just hit some of the more complicated problems. But basically here you have elimination or substitution. Elimination happens when you have none of your equations are solved for a particular variable. So this is elimination because both the x and the y are not solved. If we look at the difference here, if we look at a problem like maybe number 5 here has y all by itself. It's already solved for y. This is substitution. So we're going to do one of each, and then I'll do probably one of the harder ones, just so you can see how to do these type of problems. So the elimination one I'm going to choose. Number 3 already has elimination because you see the negative 4 and the positive 4 already cancel out. So all you have to do is just add these and solve for y, then plug it back in and solve for x. Number 4, though, is slightly more complicated zoom in here, because you cannot just simply cancel them out. This is elimination, but this doesn't cancel. This doesn't cancel. So this is where we have to do what is called forced elimination. We have to force them to match numbers. So in this particular case, I cannot multiply one equation and get the other, or one y and get the other. So I have to actually multiply both equations. And if you remember this, this is where you have to actually multiply both equations by something to get a common multiple. So let's take, for example, the x's. If I want the x's to cancel out, I'm going to need to find a number that both of these will go into. It turns out the first number that comes across is 10. So if I just get both of these to be 10, well, one to be positive 10 and one to be negative 10, I can have elimination. So the first equation I'm going to have to multiply by 5 to get my 10. So I'm going to multiply everything by 5. And I'm going to rewrite the equation over here to the right. That gives me 10x minus 35y and equals 100. The second equation, because I need the second equation to be negative 10, is going to have to be multiplied by negative 2. So that'll be negative 10x, negative 16y equals positive 2. Now I have elimination. So now the 10x's will cancel out. I add straight down. Negative 35 and negative 16 make negative 51. 102 make 102. Divide. And you get y equals negative 2. Now, I'm not quite done yet because I do need to plug that back in to one of these equations here and find out what x is. Now, it doesn't matter. You can plug it into this one, plug it into this one, plug it into this one, or plug it into this one. It doesn't really matter. I'm going to go ahead and plug it into this second one here. You'll get the same answer no matter what. But plugging it into the second equation gives me 5x plus 8y, which we've already found is negative 2, equals negative 1. When I multiply, I get 5x. 8 times negative 2 is negative 16. I then add the 16 over. Gives me 5x equals 15. Divide by 5, and I get x equals 3. Now that I have x and y, I put my final answer in an ordered pair, x, comma, y. And this is my solution. So that's the answer to number 4. Okay. Now, let's try a substitution one. The substitution ones that always kind of mess people up are the substitutions like number 7. Okay, number 7 is clearly substitution because one of my variables is already solved by itself. So in substitution, you take what this equals. So you take essentially y is this, and then you just substitute it in for the y in the other equation. If this were x equals, then I would take this and plug it in for x. But since it's y equals, I take this and I plug it in for y. So what my new equation looks like now is x plus, instead of y though, I now have 1 minus 4x, and then equals 4. Now, there is a number right here that I need to distribute, and it is a 1. There's a 1 here that needs to be distributed. So I get x plus 1 times 1 is 1. 1 times negative 4x is negative 4x equals 4. And now all I do is just solve for y. I'm going to combine like terms. X and negative 4x make negative 3x plus 1 equals 4. Minus 1, minus 1. Negative 3x equals 3. We'll then shift up here and we'll then divide by negative 3. And x equals negative 1. To find y, we're going to plug it back into the equation. I can take this here and I can just plug it back in for x in the other equation. Now you could plug it into the first equation too. It doesn't actually matter. But I'm going to plug it into this second one here. So I have y equals 1 minus 4 times negative 1. Y equals 1. Negative 4, right here, negative 4 times negative 1 is positive 4, making y equal 5. So my solution, x comma y, is negative 1, 5. That is how you do substitution and elimination. You've just seen me do one from elimination and one from substitution. So that is outcomes 30 and 32. Okay. Number 3 should be elimination. Number 5 should be substitution. 6 is also substitution, but you'll substitute it in for x because it's x equals. And 8 is elimination, though it's forced elimination because you're going to have to make one of these match the other one. Now on to number 33. By the way, you can check your answers at any time in the answer key, which is in cycle 39. Cycle or outcome 33, okay, is determining how many solutions a system of equations has. Now remember that the number of solutions is how many times the lines actually cross. So number 10 is fairly easy because if you just look at the graph, you can clearly see that they never cross. Therefore, there is no solution here. If they did cross, then they would have one solution because they crossed one time. The other answer is infinite solutions, which is when one line is on top of the other line, which is a little difficult to show on a paper. But that's what you do there. How many times does it cross? It doesn't cross any times, so there is no solution. If it crossed one time, it would be one solution. Number 9 is a little bit more challenging because you actually have to solve the problem first to figure out how many solutions there are. So we're going to go ahead and solve this. It's a forced elimination. So I'm going to make my x's cancel out. So if this is 8, this is going to have to be negative 8, which means I need to multiply everything here by 4, by 4, by 4. So that gives me negative 8x, positive 12y equals negative 20. So when I go to cancel out, 8x minus 8x cancels. Negative 12y plus 12y, that also cancels, which gives me 0 on this side. 20 minus 20 is also 0. So I get 0 equals 0. If you remember, this is actually a true statement. And the answer for a true statement is infinite solutions. So this problem would have infinite numbers of solutions. And that's how you do outcome 33. That's not a power outcome, but it is an outcome, a fairly easy outcome. Outcome 34. Now 34 is just, can you write the systems of equations word problem? So outcome 34, you don't actually have to be able to solve the problem. Okay, all you need to be able to do is set the problem up. You don't actually have to solve it. So let's look at number 11. Okay. So in these type of word problems, there are a couple things that you are looking for. When you're going through and reading the word problem, you're looking for the word per. Okay, the word per is going to tell you whether or not it's a rate problem or not. So as we read the first problem, it doesn't say anywhere in here that it is a rate problem, which means that it is a comparing problem. Comparing problems compare two different things to each other. So it looks like here that they are comparing adults and students. So those are our variables. Adults. That's a terrible. Adults equals A, and then students will equal S. Comparing type of problems, compare one to the other. So you have A plus S is going to equal something, and then A plus S is going to equal something else. Now you fill in the numbers. The numbers, okay, you can circle them, highlight them, whatever you want, but these numbers have to get into the word problem somehow. So first you start off with your totals. Okay, the 188 and the 1588 are your two totals. 188 is the total number of people, and the 1588 is the total number of revenue, money. Now that's very important because the other two numbers right here, 4 and 8, also deal with money. So you want to make sure that the other two numbers, when they're placed in here, go in the appropriate equation. You can't just put them in anywhere. Okay, since they both deal with dollars, $8 and $4, they need to go in the equation that has dollars. This one. Dollars, dollars, dollars. So the 8 goes for adults and the 4 goes for students. And that is the answer. That's it. 34, you don't even have to solve these problems in 34. You just have to set them up correctly. So that's it. Now, if we look at number 12, again, we do our little check where we read through the problem, see if we see the word per, and whoop, there's per right there. Let's see if we can find another one. And oh, there it is again. Okay, the per is going to tell us that it is a rate problem. So right here, the $24 per charm and the $19 per charm are rates. So these are going to follow the y equals mx plus b, where all you have to figure out is what is m and what is b. Well, m is rate. Now, the rate is always with the per. So if you see the per, that's the rate. So as you write these equations, y equals, the first one is going to be right here, $19. So 19x is $19 per charm. Plus, it even says plus right here, plus $29 for the actual bracelet. The other equation has the rate right here, $24 per charm. So we write that as $24 per charm and $9 for the bracelet, plus $9 for the bracelet. That is it. That's the equations set up. And finally, 13, the one everybody messes up on, are your interest problems. Again, you would go through here and see if you see the word per. I don't see the word per anywhere. So it is a comparing problem, and you're actually comparing, I'm going to use just x and y. X is going to be fund number 1 because they're doing two different funds, and y is fund number 2. Hey, there's two funds right there. Okay, it's fund 1 and fund 2. So this is going to look like x plus y equals, just like in the first one. Put our totals in. Let's circle all our numbers here. There's that one, that one, that one, that one. And the 10,000 that's over here is the same 10,000 that is over there. So our totals are 10,000 is the total number of amount of money that they're investing. $600 is the total amount of interest they want to earn. So remember that 5% and 7% are interest. Just like in the first problem, we need to place these numbers in the correct spots. 5% interest, 7% interest needs to go in the equation that has interest. This $600 is interest. So interest, interest, interest. Okay, the only thing that you have to remember is that 5% is not 5. it's 0.05. And 7% is 0.07. And that's it. You're done. Moving on. This is the last outcome in Unit 5. Outcome 35. Graphing systems of inequalities. Let's start with number 14. These systems of inequalities are graphed very similar to the way the ones that are graphed with systems of equations. You're going to graph two different lines on the same graph. The only difference is with systems of equations, where they crossed was the solution. With systems of inequalities, you have to shade the area of the solution. So, I'll do these in two different colors again. So the first one starts at -1. There you go. And has a slope of 5. So it's going to be going up 1, 2, 3, 4, 5 over 1. And there's the other dot. Now, the difference here is we have dashed lines and solid lines. So the inequality is going to be solid if it has the equal to line underneath it. If it's got the equal to line underneath it, it is a solid line. If it's missing that line underneath, it is going to be a dashed line. So our first equation here is going to be a solid line. Okay. The next step then is to draw arrows on our line. Remember, we can't shade yet until we have both lines there, but we need to draw arrows in the direction that we would shade to help us in shading later. Now, this is where you look at the inequality symbol. Okay, this is a less than symbol. The alligator's mouth always eats the bigger number. So if this is bigger, that means that y is less. So y is less than this. This is a less than symbol. So you draw arrows off the line to the bottom side of the line or in the downward direction. Okay, and you draw them on either end. The next line starts at -1 as well, but this one has a slope of 1/5, meaning up 1 over 5. I'll even go down backwards here. This line, because it's missing the inequality thing underneath, is going to be a dashed line. This inequality sign is also greater than. It eats the bigger number, which means that this is greater than this. So this is greater, which means we're going to draw arrows in the upward direction. Your solution is to then shade the area where the arrows point towards each other, which is going to be in, let's see here, this area here. Okay, that's how you do those problems. Number 15 is exactly the same thing. The only difference that people sometimes struggle with is these x lines or y lines. Okay, an x line is a vertical line. So with x is less than -4, we go to where x is -4, and we draw a vertical line. Check. Make sure, though, that this is going to be a solid or dashed line. Looks like it's going to be solid. So we'll draw a solid line. This is less than. This is a less than symbol, so you shade to where x is less than -4. Less than is in the left direction. And then finally, the next line starts at 1 and has a slope of 1, meaning we go up 1 over 1. And I can draw a bunch of these different dots. This one's going to be a dashed line. And it's a greater than, so you'll shade in the upward direction. And it looks like that this area over here is where the arrows are pointing towards each other. So I'll go ahead and shade this in. And that is it. That is Unit 5. The remaining outcomes here are previous information. So let's start with outcome number 9. Outcomes number 9 and 11 deal with graphing inequalities on a number line. Graphing inequalities on a number line is sometimes can be more difficult, but it's basically like solving an equation like you normally would. So I'm solving for t, so the first step would be to add 20. 8 plus 20 is 28. Then divide by 7, and you get an answer of 4 is greater than or equal to t. Now here's the problem with this. Normally, your inequality symbol will point in the direction that you're going to be shading, but the variable is normally on the left side. It's normally t or x equals something. The variable is normally and typically on the left-hand side. When the variable is on the wrong side, like this, it's on the right side, wrong side, you actually need to do the opposite. This looks like you would shade to the right, but since the variable is backwards, you're actually going to shade in the opposite direction, to the left. The only thing that you need to be aware of when you're graphing these, and I'll transfer it over here, 4 is greater than or equal to, so 4 is greater than or equal to t, is on the number line you just need to make sure you include at least 3 numbers. Solution goes in the middle. Okay, this is going to be a closed circle. Open circles do not have the inequality, the equal to. This is a closed circle. If it didn't have this line here, it would be an open circle. It's a closed circle. And now, since the t is backwards, it looks like it's going to go right, but we actually go left. That's how you do inequalities. I'm not going to do number 2, but number 2 is the same thing. The only thing you have to be careful with is when you get down here and you end up having to divide by a negative number, your inequality sign will actually flip around. So let's actually look at that. When you solve this, when you minus the 3, you get negative 3v is less than or equal to negative 15. So when you divide by negative 3, the inequality sign will actually flip around, and then you'll graph that. Systems of inequalities, like number 11 or outcome 11 here, are a little bit different. Remember, there's 2 types. There's an OR type and an AND type. OR types will say OR. So if you don't see the word OR, like in number 3 here, it's going to mean AND. And the biggest difference between those is AND type of inequalities should connect. They should connect the dots. If they don't connect, then we got a problem. But these should connect. OR ones don't connect. Now, they can go away from each other, or they can go towards each other, but they do not connect. Okay? Connect, don't connect. And you solve these just like the other problems. So if I zoom in here, and this one I have 2 inequalities, so I need to do this twice, so add 3 to both sides. Gives me, add 3, right? Negative 9 less than 3x less than or equal to 18. Divide by 3, divide by 3. I get negative 3 less than x less than or equal to 6. And this is my solution. So now to graph that, knowing that they connect, I'm going to build a number line over here. It has at least 3 numbers. And let's check and make sure my number's negative 3 and 6. So I can make negative 3 and just go by 3's. 0, 3, 6. And know that they're going to connect. The only thing, again, I have to make sure, open and close circles. Looks like the negative 3 here is going to be an open circle, and then this one's going to be a closed circle. So at negative 3, I have an open circle, where 6, I have a closed circle. Since it's an AND inequality, they should connect. Okay. Or ones are the same way, except there are 2 separate inequalities. So that's compound inequalities. Outcome 17 are function notation. Now I'm only going to do one of these problems because they're all exactly the same. The only thing you need to be aware of is to use the proper equation. Notice how they all have different letters. It's not a coincidence. H of 3 means that I need to use the H equation. G of -2 means I need to use the G equation. And F of -4 means I need to use the F function. So we'll do this first one here, H of 3. H of 3 equals, and I'm going to use the equation that's over there with H, is 2x minus 1. What you actually end up doing is taking this 3 and just substituting it in here. So you get 2 times 3 minus 1, which is 6 minus 1, which is 5. All you do is take whatever number is in here and plug it in for the x's. Same thing with f of -4. You would just plug the -4 into the x and solve. The answers to number 6 should be 17. Let's see. Yep, this should be 17, and this one should be 23 if you solve them correctly. The final outcome is just, can you graph a line? Very, very basic skill set of algebra. This is probably one of the most important aspects of algebra, is being able to actually graph a line. So just like we've done in systems of equations and systems of inequalities, they're all the same. Start with the 4. And then the slope is -1 over 5, so -1 over 5, and draw your line. It's really that simple. X lines, again, are vertical lines. So you go to 2, draw a vertical line. Remember, that's X. That's why it's on the X. Y is -4, which means on the Y-axis we go to -4, and Y lines are horizontal lines, like so. Now the last one always seems to trick people. People think that this is just a Y line or an X line, but it's actually a normal line. It's exactly the same as number 4. The only thing it's missing is just this piece right here. If I were to, if I can't do this on here, but if I were just to cross this out, you would have exactly the same thing that's over here. It's just missing this piece right here. That just means that it's 0. That means that the equation actually starts at 0, then does the slope of up 2 over 3. And we draw our line. That is the entire review and unit test in a nutshell. Hopefully this has helped. If you have any additional questions, you're more than welcome to come in to AL or message me on Canvas or just talk to me in person. Thanks.